based on a study.
Oh, God.
So take a look. Just now, we're not going to critique this study. We're not going to critique this study. This study probably has plenty of holes in it.
16.
But take a look at the claim. Study claims caffeine addicts get no jolt from morning coffee. Okay. How many of you would consider yourself a caffeine addict?
Probably.
Okay. How would you define caffeine addiction?
Need to have it.
How would you define need? How would you define can't live without it?
You will die without it.
I got a measure for you. If your heart rate can't get up to a baseline level without it, then you're a caffeine addict.
Okay.
See, I can measure that, can't I?
Yeah.
I'm not saying it's a good measure. I'm not saying anybody would actually use that measure, but do you see how that's a little more concise than can't live without it? You can live without caffeine. You might be miserable. You might give somebody a scale of 1 to 10. What's your pain tolerance without caffeine?
Yeah.
That's a data point, right? That's a measurable data point. But that's why I'm not picking on, well, I'm kind of picking on you. But my point is that it's very hard to define what a caffeine addict is. So if you read it into the article, check it out. The scientists studied 379 adults who gave up caffeine for 16 hours, implying that they don't give up caffeine usually, which means they must have somewhere in here, and I'm guessing frequent consumers feel alerted by caffeine. This is actually a report on a report, which means that they're not going to tell us how they expressly define caffeine addict in this thing. But that's okay. Click on the links. Find the sources. Find the sources and click on them and go track them down. I haven't done it for this because I really don't care about this particular
They're
one.
selling themselves in the streets for caffeine.
That's okay. What I care sell myself for caffeine. For caffeine. What I care about is that right there. That's what I care about, the 379, because that is my random sample. It's at least my sample. It might not be too random, but it's at least my sample. How many caffeine addicts are there out there?
Let me tell you, because lately,
Probably a bunch. More than 379, correct? More than 379? So, let's pretend for one ridiculous moment there were only 379. Just for one ridiculous moment. If there were only 379, and we collected them all into a room and made them give up caffeine for 16 hours, and they all lived and came out of this study, then we would have done what is called a census. You've heard of this. The US does it every 10 years. They count every single American. It's a dated procedure. I think it's going to go away over time. The census was invented in like what, 1777? Right after they framed the Constitution, when there was like 25 people in the country. Like, George, yes! Is everybody here? What, Tom? James? Martha? Yes, we're here, check. That was a census. Now there's 310 million people. You can't count them all. Well, they do. They annoy you at your house until they do. That's true. Right, yes. So the idea is, unless you count every single person, you haven't done a census. But the trick with this is, if you can't get the whole population, you only get a sample, then you have to measure the uncertainty. Scott mentioned this before with the map. I'm going to back this up to this, the very first thing. Well, actually, it doesn't matter which one we look at. These down here. 50.6 to 47.8. How many of you have heard the term statistical dead heat in election year? Have you ever heard that phrase? When the news is being accurate, when the polls come in, they might come in and say, Obama's ahead! 50.6 to 47.8. This is the night before the election, right? Well, right there, they don't exactly know what the percentages are. They've done a sample. So when they call it a statistical dead heat, they're admitting that that number is not that precise. It's not 50.6. It might be a couple points higher or a couple points lower.
Because the data's still coming in.
Exactly, because the data's still coming in. They don't have a census yet. They've got a sample drawn from a population. So, because these are so close, again, Taryn, this E, that E is still pretty big, which means it could go both ways. I want to talk about that mathematically with the next example. But the reason I bring up that now is because when you have this kind of a study, what's the population we're interested in here? Be as general as you want to be. Who are we interested in with this particular study? Caffeine addicts. They got a picture of coffee, but they mentioned tea and other stuff. Tea, coffee, or other caffeine-containing drinks. We'll analyze those later in class. Caffeine addicts is my population. However that's defined. What's my sample? The 379 people drawn. Is that big enough? Loaded question.
no.
Loaded question. Loaded question.
No.
Depends on how confident you want to be.
Yeah.
Depends on how much air you're willing to assume. That's why this is such a hard question for me to give you a quick answer for. That's a quick answer on a given confidence and a given margin of error. If you don't want to start with that, that could be big enough. We'll get, I promise you, Taryn, we're gonna keep answering this question as the class goes on. Not the first week though. However, we are trying to do this. We want to know the value of what's called a parameter. A parameter is a population measure. We want to know that. We want to know how much the average heart rate raises with these caffeine addicts when we take it away and then give it back to them. We want to know that. We're never going to know it exactly. We're never going to know it exactly. So we're going to get a statistic instead. We're going to get a statistic instead. And you know what? I'm going to add something to this. Is it okay with you guys if I add something to this? Sample with its corresponding margin of error. You know, because Taryn, you bring up a very good point, don't you? When you're asking for this, this formula, I love the fact that you're asking for it, by the way. But when you're asking for it, it's not just about the statistic, it's also about the uncertainty. And we're going to talk about a margin of error in just a moment on the next slide, the next study, the next Gallup poll. Let's see if that fits better. That fits pretty
I
good.
think that'd be funny on the newscasters, like, and our margin of error is this.
Dude, if they don't report a margin of error, they're lying to you. I mean, that's the downside.
But they're entertainment, that's the thing.
Well,
it's meant to be
arguable, right? Arguable.
Right.
Let's see if this it does.
I mean, it's unfortunate.
It is. I think so. It's
Because if they don't get a rise out of you.
It really is infotainment, right? But the thing about it is, if you know the parameter, if you could actually count the entire population, you know exactly what the number was. If you could get every caffeine addict in a room and measure their heart rates, you could then average those heart rates. And there wouldn't be any uncertainty. There's no uncertainty, you know it all. But if you're only drawing 379 of them, and there are hundreds of thousands, if not hundreds of millions of them, if you only take 379, you've got to admit that there's going to be some unknowns in your, and that's what the margin of error makes up for. Now the calculation of that margin of error, we have to keep developing. Faith, go!
So that's even tricky with going off of somebody's self saying that they're a captain.
Oh, God, yes! Self-report.